Hey guys, welcome back into our Python programming series. In this episode, we'll go ahead and talk about Python's object-oriented nature. We'll go ahead and cover the classes and object as the topic for this episode. So before we really deep dive into the classes and object or the object-oriented nature of Python, it's really important to understand some of the concepts around the object-oriented programming. If you know some of those concepts, very good, just hang on with me. I will not take very long. But I think it's really important to cover some of these topics before we really hands-on exercise. So if you take a look here, Python, as we kind of talked about, is an object-oriented programming language. And this has been the case since the time it existed really. So it's not something that was added later on. So the good thing about the object-oriented programming, it really allows we as a programmer to create our own objects, methods and attribute. We have been working with Python for a while, and so far we have used many built-in methods earlier without realizing maybe. Like when we created a list or tuple or dictionary, we used a couple of methods like append, really to append an element to either a list or to a tuple. If you recall, that append is nothing but a method actually. Upper, and there are many more things. The only difference between a method and a function, when we create a function inside a class, that function is called basically a method. And then we call those methods onto our object. So simply we created a list. So list was nothing but an object. On that object, we ended up calling it like an append function, or probably on a string, we ended up calling like upper or the lower, some of those methods. So when working with the large Python programming code, functions are not really enough to organize your code. And that's where the classes and objects really comes into handy, that allows you to organize your code in much more repeatable and organized fashion. So that's where we're going to go and take a look at some of the object-oriented programming terminology before we really deep dive into any other thing. So when we are working with any kind of object-oriented programming, there is a class keyword. So as the name kind of indicates, class, it's simply a user-defined prototype of an object that defines a set of attributes, and those attributes are the one that characterize any object of the class. The attributes are simply the data members, or we can just call them the class variables and instance variables and methods. And we do access them using the dot notation. And again, don't worry, we will go ahead and see some of these things into the action. So at a basic level, we would definitely need to have a class, and to define or to create a class, we would have to use a class as the keyword. Now, once the class is created, the another thing that we need to work with the object-oriented programming is the objects. So an object is a unique instance of a data structure that is defined by its class. So once you have defined a class, now let's say you want to use that class. So we'll go ahead and create an object of that class. So the object will have both the data members, which are your variables, as well as the methods. So that means any methods or variable that we have defined or declared inside a class, an object will have access to those variables as well as those methods. Again, we'll go ahead and take a look when we do the hands-on. So once we have defined the class, we'll go ahead and create an object. Now we know what is method. It's nothing but a special kind of function. It's nothing special really. It's just a regular function, but once it's defined inside a class, that function is not called just a function. We tend to call it as a method. Now the another thing with the object oriented is the instance. When we go ahead and create an object of a class, that object or that individual object of a class is called an instance. So for a class, we can create one instance or we can have multiple instances. The good thing about instance, each instance is a kind of an individual, or it's a unique instance, which will have certain common things, which it's getting from the class from where we are creating this particular instance. Then there are something called class variables. As a simple name says, a variable that is shared by all instances of a class. Think of the class variables are kind of a global variables. So that means if you want to have certain common thing across all the instance, we can define or we can declare some of those properties as probably as a class variable. That way, when we are creating an instance, those class variables gets automatically part of those instance. And again, we will go ahead and see some of these things into the action. So when working with the object-oriented programming, or especially in this case or in this episode, remember some of these concepts. What is a class, object, instance, methods, and some of the class variables. So creating a class is very simple. As we said, we would have to use the class keyword. So, and after followed by a name of a class. So if I go ahead and type, and if you take a look, when I type the class, let me go ahead and retype it. So again, as you can see, the intelligence kind of highlighting, okay, hey class, looks like we probably plan to create a class. So once we go ahead and type the class keyword, we would need to specify a name of our class. Any name, like what we have picked up for earlier functions or anything, we can go ahead and pick a name for our class. Once we have our class defined, so let's go ahead and simply create a class. We would just call it, this is a test class, and this class is not doing anything. It's just a placeholder. So we just went ahead and created a class. We are calling the name of the class is test, and within that class, we just wrote the pass means, okay, hey, we are just letting this class to be created. When we define a class, there are a couple of things, and one of the method or one of the function that we work within a class is called the init function. We would go ahead and define this function. So let me go ahead and first define this function, and then we'll go ahead and talk a little bit in more detail about this particular function. So within this class, let's go ahead and define. So we use the def keyword. If you recall, using the def, we had defined the function. So we'll go ahead and define a special function that is called underscore underscore. So there are two underscore, and the function name is init, followed by underscore underscore. And within that, if you see, I didn't have to type this, something shelf showed up here, so that's fine. Now with the self, we can go ahead and pass multiple parameters to this particular function, like as we had done earlier with the function episode. So if you see, I'm declaring or I'm defining a special function, which is your underscore underscore init, where we have first parameter being self, and then I'm passing two parameters. An example, again, you can have one parameter, you can have multiple parameter. So if you take a look, not we can use any other name. So I'm using a self here, and when we created this function on the IntelliJ, it also came up with the self. Again, this is a good practice to use the self, but again, we can have any other name. You can type ABCXYZ, and again, we will go ahead and take a look of the role of the self a little bit in a few seconds. And with that, if you see within this function or within this method, I'm passing two parameters. There is a parameter 1 and there is a parameter 2. And you can see these parameters, I'm just highlighting, color coding them, so it's easy for us to refer. So these parameters and parameter 2 are nothing but the variables, just like we did in the functions episode. So these are the variables that we are passing to this init method, or you can just call it function, but I think the correct terminology is method, because this function is inside a class. So we are passing these variables, parameter 2, to this init method. And then we are assigning the value of these variables to our two attribute. So within this method, we went ahead and create two attribute. And the name of those two attributes are parameter 1 and parameter 2. So remember, this parameter 1 and parameter 2, which are highlighted in gray, are really the attributes of your class, while this parameter 1, which is highlighted in yellow, and another parameter 2, which is highlighted in kind of a blue, these are two variables that you are passing to this methods. So this parameter 1 is not the same as this parameter 1. Same thing, this parameter 2 is not same as this parameter 2. The left hand side of yellow and the blue parameter 1, parameter 2, these are the variables that we have passed to this function or to this method, while this parameter 1 and this parameter 2 are the attributes of this particular class. So, but for a good practice, we tend to keep these same names. So whatever variable names we are passing or whatever our parameter name, it's good to have same as the variable name. So it's easy to know this variable is being assigned to this particular parameter here. Now let's talk about this self keyword. So when we are going to go ahead and create an instance of this particular class, this self keyword kind of indicates, okay, hey, this is an instance of this particular class, and we are referencing to this particular attribute or this particular parameter. So that's the whole idea behind using this self. So in this init method, we are saying, okay, hey, self.parameter1 means this attribute 1, the self for this particular object, the parameter 1, which is the attribute, has a value of this parameter 1, whichever the value we are passing. And same thing, self.parameter 2 for this object's instance, for this parameter 2 attribute, the value for this attribute parameter 2 is this variable's value, which is parameter 2. Again, don't worry, we'll go ahead and take a look at some of the example. But the main takeaway from here is, remember that this parameter and this parameter 2 are the variables that we pass to a method, while these two gray ones, parameter 1 and parameter 2, are the attributes of the class. So these attributes are not same as the variables, but for just simplicity, we tend to keep the same name, whatever the name of our attribute, we generally like to keep the same name for our variables also. So that's why it's easy for us to identify, okay, hey, this variable or this value is being assigned to this particular attribute. And that's how we can go ahead and define this special function, init function. And this init function gets called automatically. You don't have to call. This init function gets called automatically, or this method calls automatically when we create an instance of this class. So we'll go ahead and take a look at this in action. Now within that your class, we can have our own functions, and those functions are called the methods. So we can again go ahead and use the def keyword to define our function, and now it's called method. We can say give it a name for our method, and within that method we are passing the self keyword again. So this self would indicate, okay, hey, I'm referencing to this instance of this particular class, and within that method we can go ahead and write some of our code. So now let's go ahead and take a look, and we'll go ahead and see some examples of what we just went through in the theoretical part. So let's go ahead and create a class, and we'll go ahead and call this class as our employee class. So I'll use the class keyword again and go ahead and provide a name, and we'll say, okay, hey, this is the employee class. Now within the employee class, we'll go ahead and define our special method, the underscore init, and in this we'll use the self keyword, which is again to indicate. And now we are passing one parameter. The name of that parameter is name, and now we will go ahead and assign this variable name to one of our attribute of this class, and the name of attribute is also name, and we are referencing to, so we'll go ahead and say self dot name is equals to the name, which indicates, as you can see when I type name, it highlights this because this name is the parameter that was passed to this method, and this parameter is being assigned to this particular attribute. Now once that is done, so this is a very simple example of creating a class. Within that class, creating this special method underscore init, and I think I missed one underscore. Now let's go ahead and, now once we have our class created, within that class we went ahead and defined our special method. Now let's go ahead and create an instance of this particular class. But remember, in this class, now let's go ahead and create an instance. So I'll go ahead and create an instance. I'll call it emp1 is equals to employee, and within this employee I can say name, because if it say it's expecting a name, so I'll go ahead and say name is equals to, go ahead and assign some name. We can call it Rob Smith. Now what we went ahead and just did here, we went ahead and created an instance of this class, and the name of this instance is we are calling is emp1, and within the emp1, when we are creating an instance, we are passing this particular parameter name, and we went ahead and assigned a name. So at this stage, if I go ahead and do something like this, okay, hey, tell me the type of this emp1. If I go ahead and execute this program at this stage, now let's go ahead and put our print statement to get the values out, and go ahead and execute the program again. Now if you take a look, it says, okay, hey, we went ahead and created a class. From that class we derived, or we created an instance. The instance name is emp1, and as you can see, emp1 is equals to employee, and we went ahead and passed. Now we are just taking a look, okay, tell me the type of this emp1, and you can say emp1, hey, it's a class and it's of a type employee, because we know it's an employee type. Now we can go ahead and get some attribute of a class. So now let's go ahead and get the attribute. To access the attribute of a class, we would need to use the instance name. So in this case, as you can see, emp1 is our instance name, and when I do a dot, I'm being presented with few things, and one of the thing, as you can see here, it says, okay, hey, within your employee class, I do see there is a name, and there is another thing called init function. So in this case, we are interested in the name. So now let's go ahead and print the result of this and see what is inside this. Now let's go ahead and re-execute this program. So the first thing, the first print statement is just telling the type. It says, okay, hey, the type of the emp1 is an employee. It's a class employee type, and the emp1.name attribute value has Rob Smith. So that's how we go ahead and create the instance of a class, and that's how we go ahead and call the attributes of class. So to call the attribute of class, we have to refer the instance. So in this case, we are saying emp1. When we create an emp1, in this case, we are saying, okay, hey, self dot name. So that means for this particular instance, the name was passed Rob Smith. So self dot name now has a name which is equals to Rob Smith. So when we call self dot name, it's saying, okay, hey, for emp self dot name, is Rob Smith. We can go ahead and create more instance of the class if you want. Again, it's not just restricted to one instance. Now let's go ahead and create another instance of the employee class, and we will go ahead and pass a name, and we can say, okay, now let's go ahead and remove this. Now we know by this time the type of these EMPs are of the, now again I can go ahead and access EMP2, and now let's go ahead and access the name. We can go ahead and print this value. Now let's go ahead and run. So in every case, the self kind of indicates, okay, he says, hey, for me, for this particular instance, this is my name. This is me as an attribute. And for the same thing for emp2 self.name contains a value of Jack. So that means this attribute name has a different values for different instance. And that's how we can go ahead and create some of these attributes. Now in this case, now let's go ahead and take a look at a bit of that theory also. Whatever the attributes that we have been working, we have defined those attributes within the init function. And one more thing I want to reiterate. See, we are not calling this init function explicitly. Whenever an instance is being created, this init function gets executed automatically. That's what you see when we are creating an instance. That's the time we are passing name is equals to Rob Smith. So we are passing a variable. So as soon as this instance gets created, this method gets called. And within this method, we are passing this name is equals to this name, and the self.name contains really the value that we have passed. So that's the idea behind the init function. It gets called automatically. These methods, again, we can have a few more things if you want. Let's go ahead and let's talk about the class attribute before we go and add some more parameters. So think of the class attribute. These are common or same for all instances. Now, in this case, we are passing name. Let's say for this particular employee class, you want to have certain thing common for all the employees. And a good example would be the company name. Hey, all of these employees work for the same company. So instead of defining that variable or that attribute within the init, we can define that attribute as a global attribute or as a common. That means that is common for all the instance of this particular class. To define a class attribute, we would go under the class. Once the class is created, we can go ahead and define our class attribute. So now let's go ahead and call it, I'll just say, okay, hey, company name, company underscore name, and I can just go ahead and assign any corp. So what we just did in this line, we went ahead and created a class attribute. That means we went ahead and created an attribute within the class. So this attribute exists only within this particular class. As we kind of indicated, these are common for all of the instances of a class, basically. So now when we were creating emp.name, if you recall, now if I go ahead and type emp1 dot, now we are being presented with one more option as a attribute, the company name. But as you can see, we have not defined or we have not created this company name individually. So this attribute, the company name, is kind of a common for both the emp1 as well as emp2. And just to prove that, let's go ahead and try doing a print on for company.name for emp1, and let's do the same thing, emp2 dot company name. And now let's go ahead and rerun our program. And as you can see, for the first print statement, we are doing Rob Smith and the company name is ABC Corp. Now for the employee 2, the name is Jack, but the company name is same. So that's how we can go ahead and create common variables or a global variables class attribute. Now there's another thing we can go ahead and work within a class. We can go ahead and create some of our own methods. And again, just to tell you one more time, methods are nothing but the functions. When we create those functions inside a class, those are called your methods basically. So now if you see within this class, we have created class attribute and we have defined our special method, init method. Now within this class, we can go ahead and write our own custom functions, which are called methods to do some actions or operations potentially want. So now let's go ahead and maybe pass one more attribute to our special function init, and I will go ahead and call it salary. And now let's go ahead and do the same thing. Self.salary is equals to this salary variable. Now when we are calling these, when we are creating the instance of these class, we'll go ahead and pass one more parameter, and that is called salary. And we will go ahead and say salary is like 2500, and in this case salary is maybe, let's say, 3000. And if at this stage we can go ahead and access the the salary attribute also. So we can go ahead and say employee one dot, and then you can see we have one more. Now let's go ahead and call the salary for the first employee, and we'll do the same thing, print employee two dot salary. And now let's go ahead and simply execute. We went ahead and executed this particular program, and now we are passing. Now so far we have been working with this special method in it, but you just wants to have only certain limited set of commands or things that you want to be done when an instance is created. We don't want like the whole actions or the whole operations, everything is taken care inside the init method. It's best to have a new methods or different method created to take care of some special actions and operations, and that's where we can go ahead and create our own methods under the same level. We'll go ahead and define our method, and let's call in this case list employees. And because this is within the class, so you can see the self keyword, so it's referencing, it'll probably refer to one of the instance of the class. Now within this we can go ahead and take care of any action. So in this case we are printing, I'm saying okay, hey, name of employee, we can go ahead and call it now self dot name, and after that we can go ahead and define any other thing, and we can say okay, hey, salary is, we will say self dot again salary. Now what we just did here, we just created a function, a method in this case. The name of the method is list employees. We're passing again the self keyword, and the self keyword again refers to the instance of this particular class. And we are just printing some message that says okay, name of employee we are referencing calling self dot name attribute, and salaries we are calling self dot salary attribute. Now we have just declared this method. Now again, to call a method we would do the same thing like what we did in the functions episode. So now let's go ahead and call this method on your object. So to call the method on your instance, you will just simply say again emp dot. Now within that, if you can see, we are being presented with this particular method, and I can just go ahead and simply call list employee. Now once that is done, now let's do the same thing for the employee two dot list employee method, and now let's just go ahead and execute this program. And as you can see, now let's take a look at the example of second to emp dot name. So we are passing name is equal to Jack, salary is 3000, so that's what you see. The first emp dot name says Jack. The company name, which was a class attribute, it says ABC Corp, the salary is 3000. And now we went and called this method on this particular instance. So now it says, okay, hey, name of employee. So if you say it says self dot name, because I'm referencing the emp2 instance. So for emp2 instance, the self dot name has a name of Jack and a salary of 3000. That's what we see, name of employee Jack, salary is 3000. That's how we can go ahead and write more methods, and that's how we can call those methods onto our instance. That'll be for this episode. In the next episode, we'll go over inheritance and some of these special methods related to our classes. So I'll see you guys in the part 2 of our classes and object episode. Thank you.